Hello, everyone. Life, at its core, is a journey filled with questions. Some questions are practical, like what to eat tomorrow, how to pay the bills, or how to be a little happier. But some questions are strange, abstract, and have nothing to do with money or work. They're simply driven by curiosity. I still remember sitting by the window one quiet afternoon as the sun began to fade and the city fell silent. In that peaceful moment, my mind drifted far away, and I asked myself, why do we exist? What makes us human? If you strip away our skin, bones, and cells, what are we, really? A pile of chemical compounds? A strand of DNA? Or just a random arrangement of atoms? Sometimes, in the middle of life's chaos, I come back to those questions, not to find immediate answers, but to remind myself, life isn't just about living. It's also about understanding. We live on a small planet, in a remote corner of the Milky Way, inside a universe we barely understand. And yet, here we are, able to ask, to think, and to explore. And you know what? One question that has always intrigued me is, why did life choose carbon? Not a strong metal, not a lightweight gas, but carbon, a dull black element found in pencils and ashes. That question led me through books on chemistry, theories of life, and even the strangest scientific speculations about the universe. If you've ever paused in the middle of your daily routine and asked yourself a silly question like that, then this video is for you. Let's explore. Why is carbon the element of life? Why carbon? Have you ever wondered, why is all known life based on carbon? There are over 100 elements in the periodic table. Some are more abundant, some more stable, and some even more chemically reactive. So why carbon and not oxygen, silicon, gold, or iron? This video will take you deep into the microscopic world, where atoms aren't just meaningless balls, but the very foundation of life on Earth, and maybe beyond. Carbon, not the most abundant, but the backbone of life. Carbon isn't even close to being the most abundant element on Earth. It makes up just 0.025 to 0.05% of Earth's crust. Compare that to oxygen, silicon, or iron, and carbon seems like a minor player. But in living organisms, carbon reigns supreme. In the human body, carbon makes up 18 to 20% of our mass. In plants, it can reach 40 to 50%. Carbon is the chemical backbone of all organic compounds. DNA, RNA, proteins, medicines, biomaterials, and cellular energy systems. That's why organic chemistry, the study of carbon-based compounds, sits at the heart of all life sciences. Chemical flexibility, carbon's greatest weapon. Carbon has a unique superpower, chemical flexibility. Thanks to its electron configuration, carbon has 4 electrons in its outer shell, meaning it can form up to 4 covalent bonds. This allows it to bond with a variety of other elements like H, O, N, S, bond with itself to form long chains, closed rings, and complex branches. This lets carbon create molecules as simple as CO2 and as complex as DNA. The molecule that carries genetic code replicates itself and evolves over time. Compare that to oxygen, which can only form 2 bonds, or hydrogen, just 1. Those elements simply can't build the molecular diversity required for life. Carbon in the universe. On Earth, carbon seems rare. But in the broader universe, across the solar system, the Milky Way, and beyond, carbon is the 4th most abundant element, after hydrogen, helium, and oxygen. This means life based on carbon may not be a lucky accident of Earth, but a universal possibility. Why? Because carbon is forged in the cores of massive stars. When these stars die, they scatter carbon across the cosmos, seeding planets, comets, and dust clouds with the building blocks of life. What about silicon? Silicon sits just below carbon in the periodic table. It also has 4 valence electrons and can form 4 covalent bonds. Sounds promising, right? And silicon is everywhere on Earth. making up 27% of Earth's crust. So why isn't it the foundation of life? The answer lies in stability. A carbon-carbon bond, CC, has a bond energy of about 334 kJl/mol, very strong. But a silicon-silicon bond, Si-C, has only around 196 kJ/mol, much weaker. If DNA were built from silicon instead of carbon, it would break easily, mutate frequently, and fail to store genetic information over time. Silicon simply couldn't keep up with carbon in the race of evolution, at least not on Earth. Carbon versus silicon. A comparison. Property. Carbon. Silicon. Max. Covalent bonds. 4 bond stability. Very high. Moderate compound diversity. Extremely high. Lower chain formation. Ability. Excellent. Limited cosmic abundance. Top 4. Lower carbon isn't just good, it's optimal. Life chose carbon not randomly, but because it's the best choice given the physical and chemical rules of our universe. Could silicon-based life exist elsewhere? Could silicon-based life exist somewhere else in the cosmos? Absolutely. Silicon may not be perfect, but under the right conditions, it might still support complex structures and maybe even life. We can't rule out the possibility that Earth's carbon-based life is just one of nature's experiments. Somewhere in a galaxy far away, silicon might be the building block of life, and we might be the outliers. In conclusion, carbon is the element of life because it offers exceptional chemical flexibility, the ability to form stable, long chains, high cosmic abundance, strong, resilient bonds. But the universe is vast and diverse. Life doesn't have to look like what we see on Earth. And silicon, carbon's cosmic cousin, might be the hero of life in another world. What do you think? Is silicon-based life possible? Let me know in the comments. And don't forget to like, subscribe, and hit that bell so we can keep exploring the mysteries of the universe together.